how do we represent our networks, in a visual way for people? It's a pretty common practice to draw out a network for a customer or an organization so that you have a record of how things are set up and what's where. Well, we do this with diagrams and icons that represent different things within a building or a network. So network diagrams are often called topology diagrams. We're going to use symbols or icons to represent devices within the network. Some other terms that you need to know about are network interface card, a physical port, or an interface. Often the terms port and interface are used interchangeably. We're going to discuss these throughout. So example, a desktop computer now could have a wireless PCI card or PCIe card built into it so you could do wireless communications, but most of the time they have an actual physical wired twisted pair network interface card. So that would be in a computer, and that allows us to plug that computer into the wall, which then runs back through the ceiling and connects to a switch. So the LAN switch has ports on it, physical ports, and each port has a connection for a computer, printer, or an IP phone. And this is how we represent these things. An IP phone is an interesting device because these things sit on our desks and they allow us to pick up and make phone calls just like we used to in the olden days, except now they're actually computers. So an IP telephone has two interfaces on it, two network interface cards, one for the voice network, that would be cabled to the wall outlet and go back to the switch. The switch also provides power to bring the phone online, allow it to get an address and communicate. And then it has an additional port on the phone to do a pass-through. So our desktop computer now doesn't plug to the wall, well, most of the time. If we have two wires, we can actually have both things plugged to the wall, but the desktop computer now can actually cable to the IP phone, and through the second port on the phone, it provides a internet or network connection to the desktop computer. Downfall is if the phone goes down, the computer goes down. So the phone is actually a switch itself because it's got two interfaces. Wireless tablet is only communicate wirelessly, so you have to have a wireless access point or a wireless router for that to take place. Telepresence is new, so if you've been in one of the IBM rooms on campus, we have Cisco gear that allows us to have a classroom on the Gulfport communicating back to the classroom in Hattiesburg. That video equipment is considered a telepresent or endpoint, so you got two different classrooms both connected up with video cameras, and you can actually voice communicate and video communicate end to end. I discussed some of these other components earlier on in one of our other slides, so I'm not going to spend a whole lot of time on those, but these are the intermediary devices and those are the icons that represent them. If we wanted to do a symbol for a wireless, it looks like two waves, a sine wave and a cosine wave interlapping. A LAN physical wired connection is going to look like a black line. And then when we have a connection to a broadband service or internet provider, a lot of times we draw it with a lightning bolt. There's multiple types of topologies. This is the two most common. These are the two that they're testing you on in Module 1. One is called a physical topology, and the diagram down below here represents the physical topology. The difference between it and the other counterpart over here to the right, logical topology, is the physical one tells you exactly where a physical piece of equipment is as far as a room, a building, a actual rack or cabinet. So if I had to send somebody somewhere to work on web server, I would send them this diagram and they would know to go to the building where room 2158 is. They would know to go to rack 2, and then they would have a label on the actual server that said web server. There is no information about a name, so a web server could actually be www.usm.edu, but we don't represent that here. the web names and IP addresses would be represented on this other side. So you can see in a logical diagram, we show the actual connected interfaces. So you can see gigabit 01 on the router is tying us to some device that gives us broadband internet on gigabit 00. The switch 1 inside of our room 2158 has gigabit 01 connected to the router. So this is how it's going to move stuff from the LAN, from the classrooms, into the room where the servers are. So you can see the actual physical ports or interfaces identified in the logical diagram, but you can also see the network number. So we have a network number that represents the street that we live on. You can see that every network, every room, every LAN has a new or different number, just like we do when we move from one street to another when we're driving around. But those street names or these IP addresses or network numbers are identified in our logical diagram. They are not identified in the physical topology. So that's the differences.